This build should have been straightforward.
So this is the bracket, so it's not a very elaborate piece.
But this isn't just any old part. This part's going to space.
Aerospace grade aluminum, it technically can't be formed. Getting these bends without cracking the material, that takes a little bit of thought.
Bending did not go completely right.
What you do?
Probably have to scrap this part. Okay, so we got this part that we have to bend. It's for a satellite. The material specified is 7075. The 7075 is an aerospace grade aluminum. It technically can't be formed in the final temper that they want it for the job. So what we have to do is we have to start with a different temper, which is 7075O. This project also has some crazy cutouts and things, so it's what first looks like a really simple bracket is actually pretty complex and has a lot of steps in order to accomplish.
It's a pretty tight tolerance. You have to put two bends in this, and they have kind of a unique radius.
Whenever you're bending sheet metal, you got what we call stretch out. So when you make a bend, that material is going to stretch a little bit. When you have a new material, you're not quite sure what that's going to be. It's going to be off.
Well, it didn't crack, so that was the main thing we were worried about. I'm just checking to see if the stretch out's close. I know that the edge is going to be, since it was laser cut, plus or minus 3 thou. It's definitely a little long. The material's stretched more than I thought it would. One of these flange dimensions has got to be wrong, or both. Flange dimensions seem to be right on. What you do? I need to, at the very least, increase this by 1.5 thousandths. You know, the laser is going to cut. It may have a little bit of a kerf. Maybe the material was hot. I don't know what.
It took a full day of testing before we could even attempt the real run, and that was the easy part. 7075 typically cannot be formed, so we had to get this in the annealed condition first. The only way we could get that was in a material thicker than what was needed, so we had to machine it down to get the thickness that was needed. So we're just machining that down to thickness. We've got a little bit of chatter here, so the surface finish kind of sucks. So we're going to experiment to see if we can't take that out. We'll probably have to scrap this part, but at least we'll know if it works. Otherwise, we could sand that out with a DA sander with you, but might as well try to do it on the machine. So we'll try it right now. With the part machined to thickness, we could make our first real attempt at forming it.
Bending did not go completely right. This one, we had this dimension perfect. The angles were perfect, but the height was a little bit short. But I can, there's ways around it, and I got to cut another one to get back to the machine guys, and I think the next one will be just fine.
The process was finally moving forward, but then we hit a completely new machining problem.
So the part's coming out a little bit warped, not completely flat out of the laser, just because the laser gets it hot. but as long as we can get it flat in the vices, it'll cut it to a consistent thickness, and then we can form it, which will take that warp out probably.
That chatter was happening because he was taking too much off. And now if I take 85% off and then another skim cut, that may help with the chatter. You can hear it though, it gets to the middle where there's no support, it's like pushing down. You hear it start singing when it gets to the middle of the axis. Yeah, it's just there's chatter right, yeah, line right there. So just from the middle, have no strength, no support. It's vibrating when it gets to this pass right here. Usually you don't have the hollowed out center areas, but this may be savable. Maybe it'll bump this out. And this one to try to test it out. The Lato, this side is much better. See if you can DA the ends.
It'll definitely come out, but you know.
Chatter is not the end of the world. It would help to not have all of the weight reduction holes in there. It would have been nice if the material had just come in the size that we thought it was supposed to, but
it will be good. This was a little tall, so I gotta flatten it.
step one, which is get one good part, is done.
Because it's in the annealed condition, it's too soft for its application that it's going for on a satellite. So we have to now heat treat it back to the T6 temper. So we're going to fixture this up so that it holds itself in position for that heat treating process. So hopefully, if all goes well, this will end up exactly as specified in this profile. It'll maintain that profile. It's 7075 T6. Took a few tries, but it's kind of to be expected on a part like this. You know, so sometimes it's frustrating, but as long as we're learning along the way, we're better off because of it. This is American Precision Engineering. We make the stuff that makes the stuff.